Okay, YouTube, so this is Chad Hightower from Campobello, South Carolina with episode 2 on the Packard engine build. And today we're going to prepare for a pressure test. So we received an inline 8 into the shop to rebuild. And when I get these older engines in here, you know, it's a good idea to always conduct a pressure test on the engine before you invest a lot of time and money into an engine that may be cracked or ruptured. So I did receive an email. I'll leave the guy's name off of this video, but he wanted me to be as specific as possible with the pressure test. So I'll show you how I do it. There are other ways to do a pressure test, and I'm sure that shops that are specifically set up to do pressure tests, they have specialized equipment to do that. But at the end of the day, whether you have specialized equipment or not, a pressure test is a pressure test, and it's going to give me an indication as to whether this engine is worthy enough to be rebuilt. So to keep from talking anymore, let's move over to the Bridgeport milling machine, because we've got a couple of hurdles that a couple of hoops we need to jump through before we can actually start preparing to do the pressure test. So I'm gonna cut here and move over to the Bridgeport so we can start this process. So stand by. Okay, so I've got the head for this engine in a vise, stationary and clamped down in the Bridgeport milling machine, and you can see right where the thermostat housing is, obviously, that there are 2 bolts broken off in this head. And in order to do the pressure test, I want to pressure test the head and the block together, because the concern I have is like I said in the first videos, that these engines sit in a junkyard or they sit in a barn with water in them, and over time that water can freeze and rupture the water jacket, or even worse, if the water sits in it long enough, it will actually rust the material from inside of the engine and will destroy the engine from the inside out with rust. So I have another head that I could use for the pressure test, but like I said, I don't want to do that. I want to use this head with this engine to ensure that both the head and the block are sound. So I'm just going to leave the camera recording and get set up for this shot, and I'll just, you know, this is kind of how I get broken bolts out. I mean, there's a million different ways, but this is the quickest way for me. So let's get at it. So what I've done is basically just put 2 flat spots on the top of these bolts here. So I've got a nice, you know, level surface that I can, you know, kind of roughly find center of these bolts. And the way they were broken off, they were jagged, and the center drill's never gonna center up on that. So first cut was just to level off the top of the head. So I'll get the machine set up and we'll get ready for the next process, so stand by. Okay, so got set up for the next process here, and I've got a center drill set up in there. And I've just roughly taken the center drill and centered up on that stud there. And I'm just going to poke a small hole down in that broken bolt. Move over to the other one. Roughly center. And I'm just going to put a little peck mark in the center of that so I can see, you know, am I pretty close? And that looks pretty close, so we'll go ahead and poke a hole. Now those look pretty good there. Okay, so let's take a quick glance here at this center drill, and you can see that it has a couple of tapers on it, and that's why I use the center drills to get out a broken bolt, because it leaves a pretty good taper inside the bolt head, and that keeps my drill bit from walking and moving around as I try to remove material from inside that bolt head. So I've changed to drill chuck out, and I'm going to systematically start drilling this bolt out size by size until I get the material out enough to tap it. Now you can see what happened there is that I got so close on the center that it actually removed the threads with the drill bit, which is exactly what you want. I mean, that's perfect. I won't have to tap that one out. Move over and see. Yeah. So you can see in the shot, let me zoom in just a little bit. You can see in the shot where the threads are clearly in good shape. So if we get lucky on the second bolt, then I'll be tickled pink. But right now I got to dig all this material off, so I'll cut here and get set up for the next bolt hole. Alright, so we got the drill bit cleaned up, and you can see here's the material that came out of the bolt hole. So, and we did it without damaging the head and damaging the threads, and that's, you know, that's why I like doing it this way. So okay, well let's move on to the next bolt, and let's see if we get lucky. get it out here where I can look at it. And we didn't get lucky on this one, so let's see what we can do with it. Let's see if we can grab onto some of this material and see. And it looks pretty bad. Okay, I'm at the bottom. That one feels good. Okay, so there's our first hurdle in getting the head ready. So let me get that gasket cleaned up while I'm here and put my tools on up, and we'll move on to the next step. Alright, so the next thing that I like to do is I like to try to get all of the rust out of the head and the block, because rust can plug up a small pinhole and skew the results of the pressure test. So I'm going to try to get as much of that out of there as I can to keep that from happening. So we'll do that with the head and the block. Okay, so we've got the block laid on the Bobcat there, and I'm just going to show you, kind of how much rust comes out of these things and why it's so important to get the rust out of the block before you do the pressure test. So here we go.